Look, how we can prove that the square root of 2 is in fact a irrational number. So square root of 2. To prove it, we will do it by contradictions. So we will assume that it is in fact a rational number. So that means it equal to b over a when a and b are both integer. And we are going to choose b and a in the way that they are the smallest. In other words, b and a do not share any common factors. So let's continue. What can we go from here? Well, obviously, let's do a square on both sides. So square root of 2 square equal to b over a square. And that will give us 2 equal to b squares over a squares. And that means b squares equal to 2 times a squares. What does that mean? Well, that means b is even. You may say, how do you know? Well, definitely b squared is even because a squared is an integer. 2 times the integer is an even number. And you should all know that only an even number square can be an even number. An odd square, an odd number when you square it is still an odd number, isn't it? So that tells you b is an even number. So let's let b equal to 2k because it's an even number, so we can make it as 2k, and we plug this equation now into this. So 2k parentheses square will equal to 4k square. That equal to 2a square. Both sides divided by 2, we get what? We get a squares equal to 2k squares. And the story come back again. You see this equation and that equations. It's basically the same, isn't it? So that tell you what? That tell you a is also even. And that's impossible. That leads us to a contradictions. Why is that? Because we said just now, we chose b and a in the way that they are the smallest possible. They don't share any common factor. But in this case, we find out that no, that's not the case. Both b and a are even number. That means they both have a factor of 2. And that would say that this is because our very early assumption that square root of 2 equal to b over a cannot be right. So it could not be a rational numbers. In other words, it's a irrational numbers.